We like to say that version control is the operating system of software development. But what will happen if the version control was actually integrated with the operating system? That's what dynamic workspaces are all about. Let's start with a demo. Create a new workspace in seconds, even if it's huge. Suppose that will be possible, that you can just switch and create to a 113 gigabytes workspace in just 2 seconds. And actually just continue working from there and list the directories and files and work as usual. That is something that we want to achieve with dynamic workspaces. It will be very easy to check the workspace size, probably just a hidden file dynamically loading the status, something that will make very easy for users to figure out what's going on underneath. And it will be possible to download only what's really used. So you go, check the workspace size, then you go and type the content of a file just to see what's in there, and then only that part is actually downloaded to your cache. So you had 0 gigabytes, now you get 117 kilobytes after the read operation. Switch operation will be 0 time because it wouldn't actually download anything. All the access to the files and directories will happen on demand. So when you go and list a file, when you go and read a file, then it's when it's downloaded. Let's run a build, and this build will create thousands of new files. Suppose something like that. You run your build script with a build file, and it runs in 130 seconds. The reason why it was slow is that it actually had to download 4.3 gigabytes. And it also created more than 1 gigabyte of private files, actually the results, the output of the build. Now, let's clone this workspace. This will be something super fast to do because since it's completely dynamic and controlled by the underlying version control, cloning will be super fast. It will be just like a new pointer to the same data. And now, let's repeat the build operation again on the new workspace, on the new dynamic workspace. Remember, I was working on a location, then I just switched to this different one. Well, the build will complete in just 9 seconds, while the previous one was 130 seconds, and that's because the new workspace size is actually, the new workspace is actually sharing most of its data from the previous one. So as you can see here, it doesn't actually have any private storage because it's taking it from the old one. That's one of the key points. You can look at the total disk usage and it will be incredibly reduced. Of course, we'll need more elaborate reporting on a final version. Probably just saying workspace size and download it wouldn't be enough, and we'll probably need to say specifically what's on each of the workspaces. The key is that cloning a workspace just takes seconds. So you don't just get the same configuration. It's really like copying the entire workspace with all the private files and everything. This is extremely useful because it becomes super easy to simply try out a new idea without having to wait for gigabytes to be copied, and of course not consuming more disk space. And that applies not only to the files controlled or the files under version control, it also applies to build, intermediate build output and all that. Shelving entire workspaces is also possible. Suppose I'm working on my computer and then I just decide to shelve all my status. So basically everything I have, it's going to be uploaded to the server. And it includes all my intermediate build output, all my private files, the things I don't want on version control but I need to work. And then, just a few minutes later, some other colleague on the team decides to clone this workspace, this shelved workspace I just moved up to the repository into his workspace. That will be a very simple operation that otherwise would involve manually copying files from here and there, which is very time consuming. This is one of the super good features on this new system. It will be also possible to save the status of a workspace and recover it later. So same as I did on a server, like shelving my entire workspace to the server, it will be possible to do locally. So you're working on something and then you just decide to save it and create a checkpoint, and then you clean it, then you switch to a different branch, and then you go back again and restore your checkpoint, and you switch to the same old status you had, including the configuration of your repository on a given branch, and then all the local changes, and then all the private files. This is so good that we could probably apply it each time you switch to a different branch, so that it will happen automatically and you always get like a fresh copy. We'll also create new ways to interact with history. Suppose you have a directory like this with a few files and directories inside. So you now decide to go into a hidden directory. It's not listed there, but it exists thanks to this dynamic workspace file system layer. So you can actually go into a .history directory for each file on your workspace. And when you do that, you actually are physically there inside that directory. And when you decide to dir it and list the contents, you will see a list of the entire history. So what we create here is the opportunity for the developer to use their actual tools to interact with the history. So you could grep, cat, use editors, whatever on the history directly, instead of just through the command line's GUIs, or sorry, the GUIs or the command line. This is good for code, but imagine how useful it could be for images and documents. You could actually enter with your Explorer into a directory with all the files and all the images and previews for that created by the operating system itself. Finding changes will take no time since everything is under control. So this is one of the key things of having a dynamically controlled workspace. This is a file system integration, so all the operations that the user does are actually controlled. So there's no time in actually recovering and figuring out what happened. Locks will be enforced by the file system, so there wouldn't be a possible way to make a mistake. So it's very common for some users to forget they have to lock a file before editing it. But since the actual write to the file system will be controlled by the dynamic workspace system, it will prevent for that to happen. And with a tight integration with GUI, with the desktop software itself, we can show extra information like, well, the file is locked, and then we show just a message explaining what's going on, and even a way out to ask the owner of the lock to release it. The system will allow different update styles. So you could config the on-demand update style, which is the one we've seen so far. You just access the files on demand when you really need them, or you can run updates in the background. So you are in a consistent configuration when you switch to a new branch. If you list a file, you see what you expect. If you read a file, you find what you expect, but an update can run in the background. And again, with an integration with the desktop software of the operating system, we can show progress or something even when the operation was launched in a console. We create a built-in trash bin. So suppose you are working and you mistakenly delete a big file. Well, if the file was private or if you had just local changes, your file is gone and there's no way to recover it. But it will be very simple, since everything is under the control of the file system, to have control of the deleted files. So in this case, I'm just showing a trash command that goes and lists what's going on, and you see there was a big file that you recently deleted. There's another one you deleted too a few seconds ago, and then there's a way out to actually just go and recover. Same as a trash location, there can be an autosave. So suppose you go and make 3 edits to a file, then you run the autosave command and it shows all the snapshots it's been taken for the last minutes. So each time a file is saved, a new checkpoint will be created locally on the dynamic workspace. It doesn't go to the server. It's not like a check-in, but it's really a checkpoint system workspace level wide that is happening each time you save, independently of the tool you are using. So whether you're on the command line, on an editor, anywhere, you're just creating these snapshots. And then it's very easy to just go and show just the autosaves, the checkpoints for a given file, and then recover one of them by the ID given by the system. And then of course when you recover it, a new copy is created, so you actually track all changes. Of course at a certain point in time you will check in your changes, But again, you still have this local history. Benefits. Create a new way to interact with version control. Some of the key benefits are: don't wait for the version control anymore, even with huge projects. Avoid mistakes. No longer forget to lock a file. Never lose a change with autosave. Boost collaboration. Better ways to save and restore the workspace status, and also to share it even among different computers. Some of the key features: zero time update, zero time pending changes, everything is always under control, super precise move detection, auto locking, space reduction, multiple workspaces sharing storage, render even cloaked and partial obsolete, share full workspaces among computers, and the autosave feature, never lose a change again. Size reduction opens a world of possibilities, because even if you have a few workspaces, like in this example, only part of what they have will be private, the rest will be shared. Then the real size with full workspaces will be 55 gigabytes. But using this dynamic workspaces approach, the size will be reduced to just the share part plus their private files, but not multiplied by 3. And these are dynamic workspaces.